Hey guys, this is Algebra 2. Today we're looking at problem set 52, which is dealing with chemical mixture problems, and that your book calls this type A because we will do another type of mixture problem a little bit later, a few lessons down the road. But type A, what we're going to have in these lessons, or in this lesson, is some problems where we're going to have some mixtures, and they will be certain percentage mixtures, like a percentage of salt or a percentage of iodine or something like that. And we're going to have two different solutions, and we're going to mix them together to form a new solution of a certain percentage. Okay? I know it's going to sound very confusing, but I think you'll find these problems to be fairly easy. Now, we will be setting up some equations, and I want you to think about, we're going to need two types of equations. Our first equation will be a quantity equation. Okay, most of these problems are going to deal with liters or milliliters. So we're going to have one equation that's strictly dealing with the amount of solution. Okay, so that's our quantity equation. Our second equation is where we bring in the percentages. So we will use the percentages. Okay, so let's look at this first example and see if we can figure out how this is set up. Now I have a little diagram here just to give you a visual picture of what this is doing and what's happening here. Your book does similar diagrams, and whenever I do examples on the board in class, I'll set up similar pictures. So in this problem, we have a chemist has one solution that is 10% salt and 90% water, and another solution that is only 2% salt. How many milliliters of each should the chemist use to make 1,400 milliliters of a solution that is 6% salt? Now, sometimes they're going to throw some extra numbers into the problem to kind of mess with you. What we need to recognize here is we need to focus in on one type of percentage, either the percentage of salt or the percentage of water. And what I see on this problem is, since the final question is asking for or states something about a 6% salt solution, let's focus on just the salts. So we have a 10% salt solution, and another solution is a 2% salt solution, and we want to make a final solution that is 6% salt. Okay? Now the way this is going to work, we're going to have two containers. Your book refers to one container as the pouring, so we have some that we're going to pour in, and then another is the dumping. So we're going to dump some solution in, and then the mixture, I just call this the total mixture. Okay, so we have one solution that we're going to pour in, and then we're going to dump another one in, and we want our final total mixture to be some percentage. Now this pouring percentage, that's going to be our first one. This is a 10% solution. The dumping is the 2% solution, and we want to make the total a 6% solution. Okay, so that's our percentages. Now let's look at the quantity. The pouring amount, that's an amount of some milliliters of the 10% solution. I'm going to call that P. So we're going to have some of the 10% solution that we're going to pour in, and then we're going to add to that some of this dumping solution, the 2% solution, so some milliliters of the dumping solution, and we're going to add that together to make our new mixture that this chemist wants to make 1,400 milliliters of a solution. So we're going to pour some, we're going to dump some, add that together. We want this to be 1,400 milliliters. So that's our quantity equation. Now the second equation, we have to use the percentages. This is going to work fairly easy. The pouring percentage, think about what this is. The pouring is the 10% solution. So I'm going to take that 10%, I'm going to leave that as a whole number. Your book shows using a decimal form of the percent. I like to use it as a whole number. It makes things so much easier. So we're going to take that 10% times the number of milliliters that we're pouring in, so times P, plus the dumping solution is a 2% solution. So I'm going to multiply that by 2%, or just 2. And this equals the total mixture, which is a 6% solution. Now we've got to be careful here because we know how many milliliters of that 6%. We want to multiply that by the number of milliliters in the final solution, which is 1,400. So we have these two equations. Pouring plus dumping equals 1400. And 10 times P plus 2 times D equals 6 times 1400 is 8400. So now we have a system of equations. From here it should look very familiar, stuff we've already done. We can solve with substitution or elimination. Okay, what I would do is let's eliminate the D. To do that, I'm going to multiply this top equation by a negative 2, which gives me a new equation of negative 2P minus 2D equals negative 2800. Now I add the two equations together. The D's are gone. That leaves 8P equals 0.065. So 8P equals 5600. We're going to finish by dividing by 8. So P equals 700. Now this is 700 milliliters. Okay? Now the problem asks how many milliliters of each solution. So the P is the 10% solution. So we have 700 milliliters of 10% solution. So that's part of our answer. Now we also need to answer how many milliliters of the 2% solution. So how many milliliters of D do we need? Well, we wanted 1400 milliliters total. If there's 700 milliliters of the 10%, that means there's 700 milliliters of the 2%. So we have 700 milliliters of 2% solution. Here is my final answer. I have 700 milliliters of each. Now, it won't always work out that it's the exact same amount for both, but occasionally it does. Not a big deal. Okay? So once you get the two equations together, set up, one with just quantity equation and then the second one with the percentages. Once you get those set up, then it's just a matter of solving a system of equations, substitution or elimination. Okay? Let's try another problem. Again, I have the diagram there. I think it kind of visually helps you, but this time we have a druggist has one solution that is a 10% iodine solution and another that is 40% iodine. How much of each should the druggist use to get 100 milliliters of a mixture that is 25% iodine? So again, we have our pouring solution and we have our dumping solution, and this is our total mixture. Call it mixture, you can call it total, whatever you want. Okay? So the pouring solution is the 10% iodine. The dumping solution is a 40% iodine. And we want to make a new solution that is 25% iodine. And that total mixture, we want 100 milliliters. Okay? So we set up our two equations again. We have some pouring amount plus a dumping amount equals the total mixture, which is 100 milliliters. Okay? Second equation, we use the percentages. Again, keep the percentages as whole numbers. It works so much easier than the decimals. Okay, so we have our pouring solution is 10%, so I take 10 times pouring. The dumping solution is 40%, so I have 40 times D equals the total mixture, which is 25% times the number of milliliters in the final mixture is 100. So if I go ahead and multiply that out, that is 2,500 milliliters. So pouring plus dumping equals 100. 10P plus 40D equals 2,500. Here's my system of equations. We can solve with substitution or elimination. I would use elimination, and again, let's eliminate P this time. So I'm going to multiply this top equation by a negative 10, which gives me negative 10P minus 10D equals negative 1,000. Okay? From here, it's review, old stuff, Add these two together, the p's are gone. 40 plus negative 10 is 30d. 2500 plus negative 1000 is 1500. Divide by 30. And we have the dumping amount is 50 milliliters. So if D is 50, we had P plus D equals 100, then P is also 50 milliliters. Now we need to label these because it asks how many of each solution. So we have 50 milliliters of 10% solution and 50 milliliters of 40% solution. Now again, this one worked out that they're the same amount both times, or for both solutions. That won't always happen. I guess I just picked crazy problems that it did. My bad. So just be aware they don't always equal each other. You will have different amounts. But hopefully you'll see that these problems really aren't that complicated. You have a pouring amount plus a dumping amount equals the total mixture, and then multiply each one of those by their percents. You set up a system of equations and solve. Once you get the two equations, it should be easy stuff. Okay? There's a couple more examples for you to try on your own, and I'm sure I'll be able to answer questions in class. I hope this helps. Good luck.